we're going to move on to 3.9, which is writing linear equations. This is taking everything that we've done and combining it. This is page 34. Go ahead and copy these notes down because this will help you identify what you need to do with it, right? Like if I have slope and intercept, then I should write it in slope-intercept form. If I have the point and slope, I could put it in point-slope form, then put it in slope-intercept. If I have the point-slope form equation, I could still put it in slope-intercept. If I have 2 points, I can solve for slope, put it in point-slope, then put it in slope-intercept form, right? Each of these take you through the step. Always ask yourself these 2 questions. What do I have? And then what can I do with it? Pause the video and copy the notes. Okay, we're going to move on and do the first problem on this page. Again, this is page 34. Number 1. If your goal, right, all of this, the directions here say using what is given, write the equation in slope-intercept form. So all of these equations in the final format should be in slope-intercept form, which we know is y equals mx plus b. That's what we want them all to look like. Y is isolated. Well, for number 1, I have a slope and I have the y-intercept, meaning I can immediately put this into slope-intercept form. There's nothing for me to manipulate. It gives me the final answer I was looking for. Go ahead and practice with number 2. We're going to move on to number 3 here. Well, this is in point-slope form, and I can change it so that it is in slope-intercept form by distributing first, bringing everything down, and then I can add 5 to both sides to get a final answer of y equals 3x plus 20. That is in slope-intercept form. That is my final answer. You can practice with number 4. I'm going to move on to 5. I might give you a point and a slope, which means I can put this in point-slope form. So I get y minus 3 equals negative 4 times x minus negative 1. Well, I can simplify that, right? So I get y minus 3 equals negative 4 times x plus 1. Then I can distribute and bring everything down. So I get y minus 3 equals negative 4x minus 4. And then I'm going to add 3, right? Because my whole goal is to isolate my y. So I get y equals negative 4x minus 1. My y is isolated. It's in slope-intercept form. So if you look at these again, all of these are what do I have? What can I do with it? So number 2, I have 2 points. The only thing I can solve for when I have 2 points is slope. So I'm going to solve for slope first. Negative 1 minus 5, 2 minus negative 2, which gives me a negative 6 over 4, simplifies to negative 3 over 2. Well, now I have 2 points and I have a slope. Well, I only need one of those points with the slope. So if I do that, I can put it in point-slope form. Y minus 5, I'm going to use this one, equals negative 3 over 2 times x minus negative 2, or I can make it plus 2 immediately. Then I can distribute and get a negative 3 over 2x minus 3. And I'm going to add 5 to get to the other side and isolate my y. So y equals negative 3 over 2x plus 2. So I still can get into slope-intercept form. Again, it's a matter of how do I start it. This is when really knowing your formulas are going to come into use, right? You need to know your slope-intercept form formula, your point-slope form formula, and your slope formula. Question number 9. Now this comes directly from Unit 2 when we dealt with functions. You can translate this into negative 2 comma 10 and 4 comma negative 2. Do you see how I took this, made it my x, this made it my y? This made it my x, this made it my y. Well, I have 2 points now, which means I can solve for slope because the only thing I can do with 2 points is solving for slope. So I get a negative 12 over 6, which gives me a negative 2. I can use one of the points and I can use the slope to put it into point slope form. Then I can distribute, so I get y minus 10 equals negative x minus 4. And then I can add 10 to both sides. So again, I get y equals negative 2x plus 6. You are going to practice with page 34 and 35. I am going to show an example on page 36 for numbers 1 and 3, just because some people get confused what to do when they see something like this. So again, our goal is still to get into slope-intercept form, but it tells us, hey, the slope is undefined. What do we know about undefined slopes? We know that it is a Vux, meaning it's going to be an x equals equation. So slope-intercept form doesn't matter. It's a special case here. So x equals whatever the x value is, right? Because all coordinate points are x comma y, and my x value is negative 4. So right there, I have my equation. This is going to be x equals negative 4. Because in special cases, every single x value is negative 4, so it can't be anything different. Apply that thinking to number 3, right? I have a function, so I can get a point out of it. I get 3 comma negative 4. My slope is 0, so that is a hoi. I know I have my y, so it's going to be whatever my y is here. So it's y equals negative 4 because in a special case, your y is always going to be the same coordinate point or coordinate in all the points. Go ahead and complete those pages.